As you work with increasingly more complex code, it becomes more and more difficult to keep track in your head of what's going on each and every line. That's why we're going to introduce to you a special notation for commenting your code in order to make it easier to keep track of what's happening on each line. This notation is known as the Jeng notation, named after Peter Jeng, its inventor and the dean of Actualize. This notation contains two parts. The first is keeping track of the code flow. As you know, the flow of our code works top-down, meaning that Ruby reads and executes each line one at a time from top to bottom. So the first part of the notation involves leaving comments on the side of each line to indicate the order in which the lines get run. So line 1, we'll put a comment saying 1, indicating that this line gets run first. On line 2, we'll put a comment that says 2, indicating that this line gets run second, etc., etc. Now I know what you're thinking. You're thinking that this is incredibly redundant because obviously if the lines get run top down, then we know that they get run top down. Why do we have to explicitly number each line? And after all, the lines already have line numbers indicated on the left-hand column. So what's the point of this? The point of this is that in future videos, we're going to see that the code flow can actually take jarring turns in confusing ways. So yes, right now, this is ridiculously simple, but you'll thank Peter Jeng later on. Now, the second part of the Peter Jeng notation is variable tracking. This involves leaving comments below our code. Here's what I mean. Just as we added comments indicating which lines get run in which order up above, we're going to put the very same comments again down below, followed by a colon sign, and you'll see why in a second. Okay, so here's our setup. Now, let's hop back up to line 7. Here we indicate which variables hold what values at a given line. So as of line 1, we only have a single variable that has been set so far. That is the a variable. And a holds the number 1. So we're going to write here, a is 1. If we go to line 2, we can see we set a variable called b, which holds the number 2. But in Peter Jeng notation, we must keep track of all the variables that have been set so far. So we're going to say a is 1, since it still holds 1, and b is 2. On line 3, we're going to have to keep track of 3 variables. So a is still 1, b is still 2, but we have now introduced a variable called c, which holds what? Well, it holds the sum of a plus b, so that's going to be 3. On the next line, we have to keep track of all the variables by the end of line 4. So on line 4, let's look carefully. We can see that a is changing. A, until now, although it has been 1, a is now being reset to be whatever c times 2 is. So if we look on the previous line, we can see that, okay, c is 3. So 3 times 2 is 6. So a is now 6. Now b and c remain unchanged as of this line. Finally, we're going to track the variables from line 5. So we see that b is changing. So b is a minus c. So if we look up above, we can see that a is 6, c is 3. So 6 minus 3 is 3, which would mean that b is now 3, while a and c remain unchanged. So a is 6, b is 3, and c is 3. Now, if we want to confirm whether all of our tracking is right, we can add PA, PB, PC. We should expect to get in the terminal 633 if we've done our tracking correctly. And indeed we have. As our code is going to get more and more complex in the following lessons and in real life, the Peter Jeng notation can help you keep track of everything in a very methodical and systematic way.